Why we wrote this B is important because this formula for a rank 2 update which preserves the quasi-Newton condition is not unique. We can find in fact infinitely many formulas for updating H which differ by rank 2 matrix and also satisfy the quasi-Newton condition. So let's look at one more very famous update formula, which is called BFGS. This was proposed in 1970 by 4 different teams or 4 different researchers, actually, individual researchers. Including our favorite Fletcher. So Fletcher is the only person whose name appears in both DFP as well as BFGS. So the BFGS formula is actually very similar to DFP. Let me first write the formula. B k plus 1 BFGS is equal to B plus gamma transpose If you look and compare closely to the formulae for DFP, this formula is very, very similar to the formula for H k plus 1 DFP, with the only difference is you can replace B by H and gamma by delta. So this you can verify yourself, and just like we were able to compute the inverse of HK plus 1 DFP, we can compute the inverse of BFGS as well. And it turns out that this property of looking at the formula for DFP and merely replacing B by H and gamma by delta works even for this case. So this is minus of a term very similar to B DFP, delta gamma transpose H plus H gamma delta transpose, whole thing divided by delta transpose gamma. So again, you can verify just by plugging in the values of H and gamma and so on and so forth, that number one, the most important property, Quasi-Newton condition holds. Also, you can verify that H and B are inverses of each other. Just like our DFP method. Also, you can verify that update for BFGS is also rank 2. So it's obvious to see that this term has rank 1. It's not very obvious why this term has rank 1, but it does. Also we can verify if BK is positive definite, then so is the next one. So these two are not the only ways of updating formulas and visiting new points. In fact, there is a whole family called the Broyden family. And at least they have told us once that they use the term formulae rather than destinations or ports. I'm sorry. So Broyden family of formulae is the whole set of formulae for updating H, hk plus 1, and this has a parameter phi which we are free to choose. So 1 minus phi H DFP k plus 1 plus phi H BFGS k plus 1, where phi is any constant in 0, 1. If you pick phi to be 1, you get BFGS update. If you choose phi to be 0, you get DFP update. And you can actually choose any phi in between, and it will still satisfy the Quasi-Newton condition and many other properties. So this is a good, so potentially we have many rank 2 update methods. It turns out that all these methods are actually very similar to each other. So we will not go into a lot of theorems regarding this Broyden family. Instead, we will just write some of the main results and discuss the intuition behind them. So the main result about Broyden family is theorem 3.4.3 in Fletcher's book. Which says that if we do exact line search, and we are consistent in choosing the local minimum out of several local minima, in line search, then all formulae from Broyden family give the same iterates, give the same sequence of points. So this is a very nice result. Okay, so what it says is, doesn't matter if you are choosing this h or you are choosing this h, they are different, but your directions are essentially the same. They may differ in magnitude, but in the sense of direction they are exactly identical. So that means all of these methods, whether you take DFP or you take BFGS or any convex combination of these two methods by choosing a phi between 0 and 1, any value, as long as you are doing exact line search and if you are able to consistently choose the same local minimum. So for example, you may say that I always choose the first local minimum as alpha increases from 0. Then DFP or BFGS or anything in between will give you the exact same points. Okay, but suppose in DFP line search, if we are choosing this minimum, and in BFGS we hit this local minimum in our line search, then of course the methods will take different trajectories and may not converge to the same point. But as long as you consistently choose the same local minimum in your line search, exact line search, all these different families of updates are identical. So theoretically very important. Because if you can show that DFP converges for certain types of functions, then we know that everything in Broyden family also converges, provided we are doing exact line search consistently.